Hello guys, this is our PowerPoint for assessment 3, and we are group 3, and our title is analysis of pipeline insulation improvement project. Next. And our PowerPoint was divided into 6 parts, and I will give you the first part, project introduce. Next. And my name is Zhongxiang, and our project background is the humidity in the production workshop, which needs to be maintained at more than 570%. You can see the picture in the middle, and if it failure to meet these standards will affect product quality. The ice water pipes will produce serious condensation in a high humidity environment, which will result insufficient humidity. So we want to give a solution. It can add an insulating layer to cover all the ice water pipes and groups on the second floor to reduce condensation. And in this project, the construction difficulties include high altitude work, material transportation, and the project schedule management, which need to be carefully planned. Next. So you can see the picture in the right. The challenges, for example, the pipes are located in 70 meters above the ground in the return air ducts, and the construction is very difficult and require professional equipment and personnel. There are also many pipes that are scattered, and the high altitude work is very risky, and the transportation of materials is also very difficult to transport. And this is the part of first, and my team members will give you the last.
Here comes my part. It's about the key activities analyzed. So according to the whole project, we divided the aptitude about these activities. The first activity, A, is about to proper ways of construction plan and material bands. So the construction plan and material band need to be appropriate to ensure complete with the standard. The approval process involves coordination among the multiple department, and it's necessary to prepare material and document in advance. So is the first activities, and the second is the hosting of the insulation cotton into the size. And the C activity C is about the glue come into the factory. Activity D is about the scaffolding into the factory. Is about the equipment. E is about the worker into the factories. Activity F is set up a scaffolding parameter starting from the second. Activity G is about the wrapping pi in solution from high from 2 to low from 1. Then we wrapping a value group in solution. After that, we shifting the tools. So we remove and reinstall the scaffolding. Activity J is about to wrapping pi and Y group. It's repeat job. We repeat this activity until the pi in solution is complete. Activity K is the construction was halt due to the safety concern. The last activity is to remove all the material and tools and the garbage out of the factory. The normal duration about the activity A is about 3 days, and it costs about 2,400 yuan. The crash duration is 1 day, and the car is 50 6,100 yuans. The crash cost increased by 3,200 yuans and is necessary to hide the duration and cost. According different projects analyzed, and it will have the normal and the crash duration and cost. The indirect cost is estimated to be 8,000 Chinese yuan per day throughout the project duration. And the network diagram analyzed. According to the whole project, the AOM network diagram for the Pi in solution improvement project is as the picture show.
Okay. Hello everyone, my name is Xu Jingzhu. Next, I will introduce the calculation part of our group project. After knowing the conditions such as construction period and cost, we calculated that the total construction period of the normal plan is 44 days, and the total cost is 669,400 yuan. Because the cost of the initial plan is high, so it needs to be reduced to the cost based on the AON network pace analysis mentioned earlier. We compress the project and determine the crucial pace after each compression. For example, in Circle 4, compress project A by 2 days and project B by 1 day. The crucial pace is still A, B, F, G, H, I, J, K, L. The construction period is 41 days, and the total cost is obtained after calculating the direct cost and indirect cost. The table is completed by analogy. The final table shows the cost decrease in first, then increases, and then decreases again as the time decreases. The best solution is Circle 15, and the total construction period is compressed to 32 days. This solution has the lowest cost and takes the least time. Last, we can look at this slide chart. This chart can also clearly show the change in the indirect cost, direct cost, and total cost. And we also can see that best solution we mentioned before. Okay, that's my introduction. Next, my team member Philip introduce the details about activity J.
Okay, my name is Chen Yunkwan, and let me further introduce the detailed scenario, including normal program and crash program, respectively. First of all, let me introduce a normal scenario. In normal scenario, installation procedure wrapping pipes takes 15 days first, while another 10 days are spent for installation procedure wrapping valve group subsequently. It means 20 workers with 300 CNY per each working day is planned, and total 25 working days, including 15 days for wrapping pipes and 10 days for wrapping valve group, are required for normal scenario. Next, let me talk about the crash scenario. In crash scenario, it requires totally 30 number workers with 300 CNY per each working day. Synchronous installation procedures, wrapping pipes and wrapping valve group are arranged together in some period. When wrapping pipes installation by 30 workers lasted for 10 days, then wrapping valve group is arranged to commence immediately by 20 workers, which has lasted for 10 days. In this case, 5 days is saved compared with normal scenario because totally 20 days spent, including wrapping pipes installation and wrapping well groups. But additional cost, 30,000 CNY is incurred during the cost analysis. That's the end of our presentation. Thank you.